Hi everyone, right in front of you are two Z790 refresh motherboard from ASRock, and both are of the Phantom Gaming series. On my left, this is the Riptide Wi-Fi, and on my right, this is the Nova Wi-Fi. Before I begin, I'd like to thank ASRock to have provided this marketing sample for me to share with my viewers, and to Tech Dynamic to have done the arrangement on the delivery. Let's begin. Starting off with the Riptide Wi-Fi. When you do the unboxing, you will first ushered with a instruction manual, a set of SATA cable where you have one straight and one right angle. These are the Wi-Fi antenna, a ARGB splitter where you connect one end to your motherboard and it's split to three, where you can connect three ARGB devices, a sensor probe, a special keycap, and a case badge. This is an ATX form factor motherboard, and the construction of the PCB is of 8 layers. The design of this motherboard is very nice. It's stealth black, and let me just show you the imprint design on the M.2 armor shield. See? And on the rear I/O. Now, the only ARGB effects on this motherboard is located at the last M.2 armor shield, which will glow underneath. The measurements of this motherboard, starting from the top to here, is 305mm, and from here to here is 250mm. As for the thickness of the rear I/O and the side VRM, I'll start off with the side VRM. Measuring from the top of the VRM to the motherboard is at 32mm. And for the rear I/O, at the top of the rear I/O to the motherboard is at 42mm. Looking at the top, starting off with this section, you'll be provided with two very beefy VRM heatsink, and they are both aluminium. The power phase of this motherboard is at 16+1+1 with 90 ampere chokes. At this center section, this is the 1700 or 1851 socket, where it caters for Intel Generation 12, 13 or 14 processor. And this is how the pinout looks like. At all times, make sure this is closed if you're not placing any processor, as you wouldn't want to accidentally dent the pin and you can't use the motherboard. Coming down to this section, you are given 4 DIMM slot, which is catered only for DDR5. So make sure you plug DDR5 and nothing else. And this works dual channel with a max capacity of 192GB and a XMP profile of 8000. Now, ASRock have enhanced this Riptide motherboard from its previous successor. Instead of giving you 2 or 3 M.2 slot, it gives you a total of 5 M.2 slot, with the top section here generation 5, and the rest of the 4 that's located at the bottom, these are generation 4. And besides this, they do provide 3 PCIe slot, which have the top section generation 5 running on X16, and the middle, which is generation 4 at X16, and the last one, which is generation 3 X1. Now, with the top section of the M.2 and the PCIe slot, this generation 5 is controlled by the chipset, the processor. Else, for the rest of the PCIe slot and the Gen 4 M.2, they are controlled by this Z790 chipset. Now, to remove off the armor shield or the heatsink off from the M.2 slot, starting off with the top section, this is a toolless mechanism whereby you just push this button down and leave it up, and you can remove the M.2 slot, the armor shield. And it's pretty beefy, as you can see, so it will not have a problem to dissipate a generation 5 M.2 heat. So make sure this is only meant for generation 5. Do not plug any generation 4 M.2 SSD. Take note on this. Oh, speaking of which, if you were to plug a Gen 5 M.2 SSD, right, the generation 5 PCIe slot will downgrade. Instead of times 16, you will run at times 8. And this section over here where you see the armor shield for the rest of the M.2, which is generation 4, you will need to unscrew the screws and to remove the armor shield. And all this armor shield, be it the top, the middle section, or the last, they are of aluminium. And underneath of all this armor shield, you are provided with thermal pad. Now, as I was saying, there are a total of 5 M.2 slots. 1, 2, 3, 4, and 5. Plenty of storage for you to keep your games, your data, and such. And right at the top over here, there is another M.2 slot, but it's not meant for your M.2. This is meant for your Wi-Fi adapter, which is pre-installed in this motherboard. And this is a Wi-Fi 7 adapter that has a Bluetooth capability of version 5.4. One thing good about this motherboard, whereby it provides you with M.2 armor shield or heatsink. So when you purchase a M.2, right, you don't have to worry to get additional heatsink to cool off the M.2s. All is being provided. And especially at the most top armor shield, this is very beefy. So don't have to worry if you place a Gen 5 which is running very hot. This has the capability to cool it down. Now next, I'd like to talk about the locking mechanism of the M.2. They have improved that too. I will zoom in and to show you. Now on all this M.2, right, at the end there is a clip to hold on to your M.2. For example, the first slot, see, you just place in place and you just clip it in. That's it. Same goes to the rest of the slot where you have this clip. So these are all toolless. You don't have to worry to have the the tiny screws to screw and to hold the M.2, and sometimes you lose the screws. So a very nice function. So all these clips are built in this motherboard. Before I go through with all the connection point of this motherboard, this comes with a audio codec, which is from Realtek, known as the ALC 1220. Right below the codec, this is the header meant for your front I/O headphone and microphone jack, followed by a clear CMOS pin. In the event, let's say you have set your profile, be it undervolt or overclocking, and your system crash, and you're trying to go back to UEFI, but it doesn't boot. Do not panic, power it down, short this pin over here, hold 3 to 5 seconds, release, and it will clear off all your settings, bring it back to default. This will allow you to boot in UEFI. Next will be this T sensor header, or the temperature sensor header, whereby this cable is provided along with the motherboard. This end here where you have the 2-pin connector is to connect to this header. And at the other end, this is the sensor to sense temperature. So let's say you want to read the temperature of your Z790 chipset. You can place this sensor near to the Z790 chipset, and the results of the temperature will shown in hardware info. Next will be a 4-pin PWM fan connector or header, followed by a Thunderbolt header. Now in the event, let's say you want a Thunderbolt port, you will need to purchase an additional PCIe Thunderbolt port, and there is this cable. You need to plug that to this port, and in order to activate your Thunderbolt port in UEFI, you will need to enable this header. Next will be a 12-volt RGB connector, followed by a 3-pin 5-volt ARGB connector, 2 USB 2.0 port, and this is the CMOS battery. Now one thing I like about the location of this CMOS battery, whereby it's not underneath the GPU where you plug your GPU, or underneath the M.2 armor shield, which gives you the convenience over here. If you want to replace the CMOS battery, right, you can just remove from here and to replace. A very good location, I like. Though it's actually at the bottom. Next will be an additional 4-pin PWM fan header, 2 SATA port, and all this header over here, this is meant for your front I/O, power switch, reset switch, power LED, and hard disk LED. And right at the top, this is the TPM module. Looking at the front, where you have this header, now this is meant for a device for advanced user, whereby when they run the system, they want to diagnose certain errors that will show on the LCD itself, right? That device will have a cable to connect to this headers over here. Next, you'll be provided with total of 6 SATA port. Now, in the past, some of you might have experienced, if you were to populate any of the M.2s, right, you might sacrifice some of the SATA port. But for this board, it's built unique. Reason being, right, even if you to populate all the M.2s, you can still make use of this full 6 SATA port. And this are catered for your 2.5-inch hard disk SSD or 3.5-inch SSD. So there are plenty of storage. You can fill up all the M.2 port and to fill up all the SATA port, not an issue. Next will be this 3.0 header, which is meant for your front I/O type A port. Another 4-pin PWM fan header. This is meant for your front I/O type C port. A 24-pin header. This is meant for you to connect your PSU 24-pin connector to this header, which will supply the power to your motherboard. Followed by a 4-pin PWM fan header. Along the top, you'll be given 2 more 5V ARGB 3-pin connector. And over here, this is meant for you to connect your CPU fans or the CPU pump, which gives you a total of 2 additional 4-pin PWM fan headers. And over at this end, where you have 2 EPS 8-pin connector. At all times, you should be connecting to one. If you are not doing drastic overclocking, you just run at default, or maybe some slight overclocking, just plug one. Unless you are doing extreme overclocking, want to pull to the max, and you need stable recall current and such, then plug 2. Or even if you're doing LN2 overclocking, which is the liquid nitrogen overclocking, then plug 2. It will give more current to your processor and to your VRM. At the rear I/O, starting from the top, this Wi-Fi socket where you plug your Wi-Fi antenna to this socket over here, and you get to enjoy Wi-Fi 7. And it also supports Bluetooth version 5.4. Right at the bottom of this Wi-Fi socket is the HDMI port. It supports version 2.1, followed by a display port that supports version 1.4. And you'll be given total of 8 USB type A port, whereby the first 2 over here in black, these are version 2.0. The rest of this are version 3.2. But there is a difference. Starting off with this 4 port 1, 2, 3, 4, they are of generation 1. That has a transfer rate of 5 gigabits per second, which is this 4. And for this 2 over here is generation 2, which has the capability of transfer rate 10 gigabits per second. And you'll be given a USB type C port over here, which is generation 1, that is catered at a transfer rate of 5 gigabits per second. But as for the front I/O type C, right, is full 20 gigabits per second, which is a generation 2.2. Now at the top of this USB type A port, you have this RJ45 port, whereby it supports up to 2.5 gigabit. This is a Intel E3100G port. Next, you have all the audio ports, whereby you have a line in, speaker out, and a microphone jack. Fun fact, how long does it take for this system to load to UEFI? I've already plugged in my 14700K processor and the DDRMs and such. These are the basic. I've not done any plug-in on M.2s or installing any Windows. Just a very plain setup. Now there's a timer over here. I will turn on my system. So this is on. Later on, when you see there's a blink over here, right, in fact it's my remote control. So when you see a red blink over here, right, that means to say it has initialized the start. And when that does happen, right, I will click on the timer over here. So let's begin. So this system itself is running through a RAM training where it takes all the readings and configuration by default and to load to UEFI. And this is how long it takes to load up. As you can see here, the time is ticking, and as I'm talking. Now there are other stuff that I really like this board, which I will be talking about it at a later stage once this demo on the UEFI, as you can see, is loaded. So it takes about 36 seconds to load to that. Okay, and fully loaded. See, you have this. So just press F2 or F1. Done. It takes about 51 seconds to load to UEFI. And this is the interface of the easy mode of UEFI. On the easy mode, you will be looking at things like what processor you are using, what RAMs have been populated in the DIMM slot, and if you have plugged in your M.2, your SSD, and hard disk, it will show you over here with all the ports, like the SATA port and the M.2 ports, or should I say slot. Over at the midsection over here, you'll be provided with the CPU temperature. This is a live graph, and you will show the motherboard temperature, the CPU voltage that is drawing currently, and the CPU quality. I'll talk about the CPU quality at the advanced mode. Now on this section here, it says load Intel base power limit. What it does is, if you enable this, right, it will take the max wattage of your processor. Let's say for the example over here is a 14700K, it can handle up to 253 watt max. So if you enable this, right, the system will not draw anything above 253 watt. That is actually to pump your clock speed. But if you know that you can do better and you don't mind to cross over the 253 watt, you can just disable this. By default, it's disabled. And so what it does is the system would pull based on the cooling solution that it provided, right? You just pull and to pump up your clock speed. I mean the CPU clock speed. So at all times, right, this is actually at disable. You can enable it if you want to safeguard your processor. For me, I just leave it. Next will be the fan status, whereby it will show you whatever fans you have populated on all the fan headers, and it will show you the RPM that's running at. And to configure the fan curve, right, there is this button on my lower right which says fantastic. If you click on this, right, this will bring you to a graph whereby all the fan headers are listed over here. You can do them individually one by one, and depending on your configuration, let's say you want CPU fan 2 to monitor, okay, I will take the chassis fan, not the CPU. Let's say for example you want your chassis fan, your intake fans, to take the readings of your CPU, okay, monitor CPU. You can just click on this and to do your curve. And to do this curve, right, you need to click on custom. This is where you set, for example, let's say right now it's at temperature 30 degrees and it's running at 32 PWM, meaning you say your fans are running at 32%. If you want it higher, you just pump it higher. See, at 30%, I'm setting the PWM to 49%. So your blade, I mean your fan blade from the front will run faster. And of course, when you do all these settings over here, right, be it the 0.1, 0.2, 0.3 and 0.4, these are the few points. As you highlight, as you can see on my lower section, right, these are the points that you can plot. So once you have done that, right, just click on apply and you will save the setting. And you can do this individually to all the okay, I'm not going to save, individually to all the fan headers. And you can select either to monitor the CPU, your motherboard, or the sensor that comes with the motherboard, the cable that I earlier on mentioned. You can do that. And if you wouldn't want to do your custom curve, right, on all this point, you can set the ASRock profile. You have silent, you can see the curve over here. You have standard, slightly higher. Performance, more steep, or full speed, which is flat line. Okay, let me just exit this. So this is how you do the fan curve configuration in easy mode. Over at my top right, this is where you can set your time and date accordingly to what time is it based on your region and the date. For boot priority, now I have not populated any M.2s or any SSD. If you did, right, and they holding on to OS, operating system, things like Windows 11, Linux, what this boot priority means is that when you select or move, drag and drop that particular M.2, okay, take for example, I take M.2 slot 1 and slot 2. Slot 1 is Windows 11 and slot 2 is Linux. And showing on boot priority, right, the first one is slot 1, which is Windows 11. Next will be the Linux. So if you want to boot default at Linux, you just drag the M.2 second slot up, and when you save these settings and you reboot, right, it will boot to Linux instead of Windows as default. So this is how it works. Next will be instant flash. This is whereby you want to update your system BIOS. So this is how you update. Of course, right now I don't have a USB thumb drive with the latest BIOS, so I'm just showing you, and it will show you the sign, what need to be done and such. Now at the top section where you see all these buttons over here, I'll start off with the info, help info. This is where it shows you how you navigate the section over here using shortkeys. See? Next will be load default, assuming that you've done your fan curve, okay, and you do not want those settings that you have saved individually, and it's going to be a hassle if you do click on individually and to do the points. So instead of doing this, right, you can just click on this here, load default. Once you load default, right, okay, take for example, I've enabled XMP profile on my RAMs and done all the curves. If you want to reset everything, just click on load default, and all the default settings will be back as normal. So this is how it works. Discard changes. Let's say you need all the changes and you don't want to save, you can just discard. Now for polychrome RGB on, take a look at this over here, the live feed, where you have the ARGB effects underneath the M.2. Now in order to turn this off, right, just by one click button, turn off. See, it's off. If you want it back, just turn it back on. Now of course you can set the languages. In fact, I'm using English. You can choose whatever language that you prefer. So let's say I put to this. See, it's all in Chinese. I will put this back to English. Now coming to the advanced mode, as this is the easy interface, it's just one click at a time, so you won't bring you to in-depth configuration like your RAMs, your PCORs or ECORs. So you will need to switch to your advanced mode. Now for advanced mode, it's either you click on this button over here or you press F6. It will bring you to the advanced mode. The first section you see in the advanced mode is the main, where it shows you what processor you're using, the RAMs that is populated in your DIMM slot, and on my right, this is where it shows the temperature of the CPU, your motherboard, the vCall voltage that it draws, and these are the additional info. Now for the OC trickle settings, where you have three sections, starting off with the CPU vCall compensation to the CPU indicator. Now for CPU vCall compensation, this is meant if let's say you're on default settings and you run your Windows and it's not stable, it crashes certain period, what you can do is come to this UEFI and set the vCall compensation, and you can set the level. And the higher level that you go, right, you will pump more vCall to your, the voltage to your processor to run it stable. But I don't see there's a need to do so because most of the configuration by default, right, is stable. This is only on the last emergency that you need to set, but most of the time just set it to auto. For the CPU cooler type and preset power, now when I plug my liquid AIO and have the RAM training, right, the system itself, or should I say this motherboard, will automatically detect that I'm installing a 280 liquid cooler and will set at a power drawn max of 253 watt. Now this is good for beginners and for people who want to safeguard, to ensure that you will not overdrawn power and to damage your processor. But for those of you adventurous and overclockers, right, you don't want to limit the power, even though your processor is at a 253 watt capacity, you want to do overclock more. You can set it to 360 or 420 liquid cooler, where it has a unlimited, as you can see here, unlimited voltage drawn. So you can set that, but for me I'll just leave it at 280. Now base frequency boost, this is whereby if you have set this to 360, unlimited, then you can trigger the base frequency. So based on what you want, and ASRock have done a beautiful job on this. They wouldn't want you to draw much more power over 400 watt, so they have limited, max is up to 320. So you can pull this during a short burst period of time, not an issue. But just make sure that when you want to use this, right, make sure you configure this to unlimited. If not, when you set this to 250, right, no matter what you set over here above 250, right, it will not react. Okay, for example, let's say you set to 300. When you run the system, right, it will, oh, okay, right now they have automatically do this. See, this is what I meant. If you want to run beyond the specs, right, it will just configure 360 420 liquid AIO. If you were to do this, right, see what happened. Oh, it doesn't trigger back. Okay, anyway, even if you set this, right, under this, even if you set 320 watt over here, but your system will still take the readings as you're running a 280 cooler at a max power limit on 253 and not more than that. Okay, let me just set this to auto. So this is how it works. Now CPU indicator, this is whereby it'll tell you your CPU quality on your P cores and your E cores, and this is how it looks like. It will show you that all the 8 cores, right, max safe gauge to draw on the B core is 1.374. If you do more than that, right, probably you will hurt your processor, so take note on this. So based on this thing, right, you can judge what you can do on your overclocking, and to tell you the P core and E core, the quality, and the CPU quality in fact is the average of the P core and the E core. That's why I'm getting 84. In the event if you get lower than 84, right, for CPU quality, right, probably 77 or so, right, don't be discouraged, as there are ways and means to help to improve your system to boost up to that clock frequency that you wanted. And the rest of the status over here, I don't have to mention about this. I believe gamers will know this. Top 1%, top 10% as such. So it gives you an average of what this processor can do, or what your processor can do. Other than that, over this section here, this is where you do your manual undervolting and overclocking. I will only show you those that I use, and in the meantime, go through. First off, I will set the XMP profile on my RAMs, which is under this section, DRAM configuration. I will load the XMP profile and just leave it. It will just run at this configuration shown over here. If not, if you want to be more challenging, you can set your own latency, your tight timings and such. All these are listed below. Next, I will play with is the CPU configuration, whereby you can set your P cores and E cores. You can set all cores to run at whatever speed that you want, and to trigger the offset on the AVX2 and such. But for me, I'm a lazy person, I just set it to auto. The only thing that I touch, okay, just to slow down, you can set all this over here manually if you're doing overclocking. For me, right, I like the style of undervolting, so what I only touch is the long duration power limit and the short duration power limit. What this does is that you limit the power drawn. I know the max power drawn of this processor is 253 to run at 5.6 gigahertz, and the temperature is 95 degrees Celsius, which I wouldn't want my processor to run always at 95 degrees Celsius when it's at load. So instead of doing that, right, I will pump down the voltage manually, as in the long duration, meaning you say throughout, to cap at this voltage. And for short duration, right, it's a short burst at random, I should say random period. You will just burst maybe 4.8, 4.9 or so. But most of the time, I would just want my processor to run at 5.2 or having a boost, random boost, right, at 5.6. So what I will do is I will limit this. Of course, this you will need to fiddle and to play with. The sweet spot of this 14700K that I've calculated is 210. So I'll set this to 210. So at this voltage, right, it's able to run at 5.2 and a random boost at 5.6 to 5.7 is more than enough. And my temperature, having this setting lower down, right, is at 86 degrees Celsius instead of 95 degrees Celsius. And to further enhance on the temperature, I will continue to configure the offset. Okay, before I do so, right, these are the things that you can do over here manually. So these are the only two that I play with to power limit the processor from drawing power. Next thing I'll do is the V-core configuration, which is the voltage configuration. Now, as usual, you can set all this manually yourself, but I only play with one standard configuration. That is to have the voltage mode at stable. If you are challenging enough and such, right, you can go with overclock mode. Okay, this is actually God mode for overclockers, but I'll just set it to stable mode and to play with the offset on the CPU core, I mean the V core. So I'll set it offset, and to set this at minus 100 most of the time in most of the ASRock motherboard adventure, I should say, on Intel or on AMD is slightly different. On Intel itself, right, I will just set it to minus 100. It just works. Reason for this, right, what it does is, assuming that you're running default, which is 1.41 volt, in order for the processor to run at a consistent of 5.2 gig and a random boost clock of 5.6 gig. That is by default. So what this does is it will limit down, or should I say, telling the system, hey, look, you have to judge yourself. Do you require 1.41 volt to run at a 5.2 gigahertz clock speed and a random boost of 5.6 gigahertz? So by limiting minus 100, you're being the boss, telling the system, hey, look, I don't want you to run at 1.41. Instead, I'm giving you a offset, as in like, take this figure and calculate, pull down the V core, and to give me a good performance. So this is what it meant. So by setting this to minus 100 MV, which most of the other motherboards, right, is in fact minus 1.1 volt. Okay, and it happened that when I try other boards, right, you can only max do up to minus 0.05 volt, which is minus 50 over here. Because this is calculated in millivolts. Oops. Okay, I can only do up to here. But miraculously, for all ASRock that have tested on, be it 12 gen, 13 gen, be it 13 gen or 12 gen, be it 13 gen or 14 gen, right, I can do straight minus 100, no problem, which is 0.1 volt. And this is the max that you can go. So having to set this, right, instead of drawing a 1.41 volt to run my processor at a 5.2 consistent and 5.6 random boost at a temperature of 95 degrees, instead is running on 1.2 something, which is so much lower, and the performance sustained at 5.2, and the random boost is at 5.6 or 5.7, and even perform even better. Plus, the temperature have lowered down. As mentioned to you, when I do not do the offset, just to do the CPU limitation, right? My temperature, which is this, when I set only this, right, my temperature is hovering around 85 to 86 degrees. And if I were to do the offset, which is this, it drastically dropped all the way to 79 degrees to 80 degrees Celsius. So these are the two things that I will play with. So for yourself, depending on your processor, you can do the same if you want to apply my method. But just be mindful that when you do all these settings, right, make sure it's negative value and not positive, because you can do positive here. See, you can do positive. So make sure it's actually a negative value. See, for positive, right, look at the idle time right now, it's going up. So make sure you pull it down. I'll just make it as minus 100. So these are the settings that you can done with this manual clocking, be it overclock or undervolt. And of course, once you have done all this configuration, right, you can save the profile under this section over here, the bottom section, where you have profile 1 to 10. You can save to this profile and to rename it. And sometimes when you reset the system, right, as in like to clear the CMOS, bring it to default settings, you can load the profile of what you have saved. When you do clear CMOS and such, right, you will not remove whatever you have saved over here. Next will be advanced, where you have CPU, chipset, and etc. I'll start off with the CPU configuration. This is where you do your hybrid threading and such to enable them, or to enable the P-core and to disable the E-core. Some of you do that, as in like you want to play games, you don't require the E-core, so you set it to 0. Then heavily depend on the P-cores. But for me, I'll just set it all, as I use this for work too, and all the C-state, etc. Now, probably you need to do a read up on what this does. I don't really actually bother about this. Then you can set all this setting. By default, all are enabled. As for the legacy game, it's disabled. If it happen that you have some legacy games, right, old games, right, you want to play in your system, you can enable this. Now, chipset configuration, this is more interesting, whereby you can determine, first thing, to make use of onboard graphic card and ignore the discrete graphic card, which I don't think you guys will do that. So just set it to auto. If it does not have a discrete graphic card, you will make use of the integrated graphic on your processor. These are the resizable bar configuration, the clever access memory and such. VTD, this is meant for virtual terminal devices, whereby you run VMware and Sandbox in Windows platform. So this will allocate the RAMs for you to cater for your Sandbox and your VMware. All this, I wouldn't have a clue what this is. Now, coming for the DMI link speed, in general, is Gen 4. Right? Now, for the PCIe lane, or should I say slot 1, slot 2, slot 3. The first slot, you're able to trigger generation 5. The slot 2, you're able to trigger generation 4. And the last slot, which is the PCIe 3, Gen 3. Now, why do you declare all this? Assuming you have plugged a graphic card, and I know the graphic card is running on Gen 4, and you have not plugged anything on the second slot, I'll set it to auto. And the last card, I'll set it to Gen 3. Let's say you plug in a capture device. So when the system boot up, right, you're telling the system, hey, look, don't have to diagnose. I'm making use of this device, as in like first slot Gen 4 and last slot Gen 3. So don't do the auto detection and diagnose. It's a waste of time. So your system will bypass that, and you will feel that you are booting your system much faster. So this is what you meant. And of course, you can set it to auto if you want the system to do some work. Just leave it. Now, over at this section over here, starting from the PCIe Express native control all the way to DMI ASPM support. Now, this, it will be useful if you are using a discrete Intel Arc 750 or a 77 graphic card, or even the lower version, as in like the 580 and so. Reason being, right, during idle time, many have found out that the wattage drawn from this card, right, is very high. It will draw 40 watt at idle, as compared to Nvidia or AMD cards, where it draws a max wattage of maybe 8 or lesser in terms of idle period. So in order to tackle that problem, right, you will need to read up how to configure all this to bring the idle wattage down on the ARC card, or should I say the discrete ARC graphic card. So there are configurations that need to be done. Do a read up on the internet. Now as for this, right, at the bottom section, these are all your rear I/O ports. Take for example, let's say you are using a discrete graphic card and together with the integrated graphics on your processor, and you have two monitors, one for discrete, one for the integrated. You can leave this at auto, or you can disable it, meaning to say you don't allow to make use of the discrete you don't allow to use the integrated graphic on the processor with your discrete graphic card. Now when you disable this, right, this is only useful for content creators, whereby you use the AVX tool on your GPU for 3D rendering and such. So when you disable this, right, all the acceleration job, or should I say the process, will be depending on your graphic card only, discrete graphic card, and not your onboard, or should I say the integrated graphics on your processor. So this will save time and the cycle of the rendering time and such. I'll just set it auto right now. Now this, as usual, your Ethernet card, the RJ45 connector, which is the Intel E3 100G killer card. You can enable or disable. If you're using Wi-Fi, you can disable this, save system resources, and the wattage, not very much, but it's still a saving. Then onboard audio, normally I'll disable this, reason being I'm using an audio interface. If not, you can just leave it enabled. Then the rest, I don't really have to go into it, except for the last section, RGB LED. Now on the easy mode, I've shown you that right at the top here you can turn off or turn on. On the advanced mode, you can do this under this section, RGB LED on, and you can turn it off. See, it will just off. And restore onboard LED default, right, this is meant like you want to reset the debug error. If let's say the light stays there and you know that your system is working, you can just reset this. So you just refresh everything. Alright, next will be tools. This is something which I enjoy using a lot when I want ARGB effects on a system. I don't have to install, okay, for all ASRock motherboard, except for some exceptional, but majority of their motherboard, right, have this built-in ASRock Polycom RGB program. See, this is how it looks like. You don't even need to install this on your Windows platform, whereby it takes up system resources and such and running on the background. Instead, you can configure straight from the UEFI. Right now, as you can see, right, it's rainbow. You can select according to what device you plug on the motherboard, the ARGB strips and such, or maybe fans and such. Now right now it's actually the heatsink, which is this, the M.2 heatsink. I'll just select this. You can select to do the color you like. Let's say I want static. Okay, right now it's black. As you can see, anything over here, because over the chart here is black. See, it reacts accordingly to what I've set over here. It's instant. See, look at it, look at the colors. When I do this, it's instant, no lag, no nothing. It's pretty straightforward. And of course, you can do effects like breathing. See, based on the static color that I've done. Or you can do strobe. See, you will just do that. And you can do a speed. You will just strobe. So these are the neat features that you can do on this motherboard just by the default application within UEFI. You don't even have to install this application. This is one thing that I like. Okay, right now I'm just going to set back to rainbow. Okay, good function. I like this. Now next is also another fantastic integrated kind of interface. Now if you're having issues with certain components on your motherboard and you want to raise certain concerns and you want to troubleshoot with the help of the ASRock support group, you can come to the UEFI and to trigger this UEFI Tech Services. And what this does, right, it will bring you to this submission form whereby you type your name, your phone, your country, your email address, your language, and your OS, and type the subject of what you're facing, and to put down in description of what you are facing. And of course, if you have pictures that you take screenshot of and such, right, put it in your thumb drive, you can attach your picture over here or screenshots. And what this does when you submit it, right, it not only submit whatever you have typed here. In fact, what this interface will do is to capture all the UUID of your PC components. Take for example your processor, your RAMs, your graphic card, your M.2s and such. It will grab within the motherboard and to submit together with what you have described. This is so time saving as compared to submit the form online on the internet, whereby you have to type what are the things that you use, the PC components like your processor, your RAMs and such. Is a hassle. So you spend a great deal of time typing all the system specs before you type the description. Else this, right, you don't have to worry about any PC components. Just type in your name and such, fill up this few fields over here, right, with your description, submit. And this will automatically draw all the PC components that you're using. And I noticed that by submitting this through this way, right, your response time will be much faster. It takes less than 2 days. In fact, on the same day, if let's say they are on operation hours, right, they will get back to you, or even to the next day. It won't stretch more than 3 days or 4 days. Else, if you submit on the web, or should I say on the internet itself, right, it takes max of 3 days, and sometimes even longer response due to the fact that unclear description and unclear components. So it becomes like a ping pong here, ping pong there, whereby they will ask you, what device you're using, what RAMs are using and such. So save your time. If you have problems with this motherboard on certain device, right, and you need to resolve this, make use of this interface. It's very direct. Alright, come to the SSD Secure Erase tool. This is whereby you can do a secure erase on your M.2, but do take note that if your M.2 have its own application in Windows to do the secure erase, make use of that. As I've encountered one time where I do a secure erase on a particular M.2, not going to name it, my M.2 can't boot, can't load, can't write. So at all times, check, make sure your M.2 has an application, make use of that. If not, you can try this, but at your own risk. Next will be NVMe sanitization tool. This is just a straightforward, simple, quick format. It doesn't do secure erase, but you just do a quick format, so you can reuse the M.2 that is stored in your motherboard. Auto driver installer. This is meant when you have set up your whole system over here and you have installed Windows. For the very first time when you boot up to Windows, right, a prompt from ASRock will tell you to install the relative motherboard drivers. So this is what it does. A very good features, and it only does one time. Even when you have this enabled, right, the next time when you boot up, right, the system will detect, there are drivers there, so need not have to prompt the user to install drivers. Unless the driver is new, then it will prompt. So this is what it's all about. Next will be instant flash. This is, again, as I mentioned, on the easy mode. This is for you to flash your latest BIOS of this motherboard, and these are the instructions and such. Next will be the hardware monitor, where you can see at the top section over here, these are all the stats on the RPM of the fans. I know that I only have one, which is the radiator fans. So these are the RPM that's running on CPU fan 1. Now take note that for this board itself, right, in fact most of the ASRock motherboard family, the CPU fan 1 is rated as 1 ampere, and for the rest, right, are rated 2 ampere. But for this board, it's special. For CPU fan 1 and chassis fan 5, they are rated as 1 ampere, and the rest, CPU fan 2 all the way to chassis fan 4, they are rated 2 ampere. And how do I know this? I read the specification on the website itself, and also there is an indication over here where you can tell straight whether is it 2 ampere or 1 ampere. For CPU fan 1 and 5, right, there are no slash water pump switch. Like you see here on CPU fan 2, you have the slash water pump switch. So as mentioned, CPU fan 1 does not have that, so it's running on 1 ampere based on the specification on the website itself. And for chassis fan 5, same thing, there is no water pump switch, so it's 1 ampere. The rest, as you can see, right, from CPU fan 2, CPU fan 2, chassis fan 1, all the way to chassis fan 4, you have this water pump switch. And having to say so, right, as you can see, the overall stats over here is showing you the title as CPU fan 2 and such. These are running again 2 ampere. It doesn't mean that over here, right, you can change this. For example, let me just pull to, for example, this CPU fan 2, you can switch this to water pump. Be it whether you switch it to CPU fan 2 or switch it to water pump, it's still running 2 ampere. It's just an indication. Let's say you have plugged this to a water pump, it will show over here. Now on the configuration side, I know a lot will like to make use of this fantastic tuning to do your fan curve individually with all the profile or maybe custom. For me, I do not like to use this. I like to do manual configuration. Take for example the let me just take chassis fan 2. You can do this on all the configuration over here on all the settings. Now take for example chassis fan 2, right, is the front intake fans of your case. I can set this as PWM mode. Then you can select the profile that is set by ASRock, which is silent, standard, performance, and full speed. But for me, I will set to custom, whereby you have total control. You will tell the system what you're monitoring, be it your CPU, the motherboard, or the T sensor that you plug in. For me, I will set it to monitor CPU. So it will activate the fan curve depending on the temperature you have set that detects on your CPU. So for example, let's say these are all the points, which is temperature 1, temperature 2, temperature 3, and 4, which you will see over here. Okay, let me just show you. These are the points. See, 1, 2, 3, 4. So back to where the manual setting is, where I told you that I like manual configuration. See over here, these are the point 1, point 2, point 3, point 4. So assuming that your CPU is running 30 degrees Celsius and you want your fan to pump at a 40% RPM, so that will pump. Or second point, if let's say it's running off at 60 degrees Celsius, you want it to pump at 80, and so forth. So you can set all this manually. I like to do it this way. It's not confusing to me, maybe to some of you, but you have total control. And best part of all, right, once you have done all this setting over here, and at this critical temperature, if you do set at a temperature, let's say for example 70 degrees Celsius, it will bypass all this configuration that you've done previously on all the points, and you will just ramp your fan to 100%. This is a safeguard thing that ASRock motherboard will do. So once your CPU reaches 70%, right, you will ignore all this configuration that you've done and to pump your fan to run at 100%. Next will be allow fan stop. Well, this is for some of the fans that allow to run at 0 RPM. If you have that function, you can enable this. If not, you can disable this. So this applies to the rest of the configuration of all the headers, inclusive of the 1 ampere. Okay, you can set this as custom. See, you have all the functions, I mean total control on all the curve points of your fans, and depending on what you monitor, as mentioned, CPU, motherboard, or DT sensor. Okay, next on security. Now for security, right, in the event you have set all the UEFI configuration and you allow your system, I mean you let your sibling to play with your computer but don't want them to touch your UEFI setting, you can set a supervision password, or if you allow them to use but you don't want them to know your password, you can set a user password. Next will be secure boot. I have not plugged in my M.2. In the event you games that require secure boot, this is where you will need to configure, especially games like Valorant. You need to enable the secure boot and to set this as custom. Then you'll be able to play Valorant, because Valorant need this. Now do take note when you set this settings over here. In the event if you want to update your BIOS on your motherboard, make sure you set it back to standard. Okay, if not, your motherboard will not do the BIOS flash. So take note on this. Now besides this, next will be the boot. All this I don't have to mention much. I believe some of you have played with it. Okay, and for this section over here, CSM. Now when you have your graphic card set to resizable bar on, you can't use this. This is meant for legacy devices. Unless you really want to use legacy devices and disable the resizable bar, then you can trigger this as enable. See, it'll tell you. Now, the last point where you have all this, I think these are self-explainable. You save all your settings, you exit, reboot to Windows, you discard charges, whatever changes you have done, you discard the charges, it will take the last reading and exit, and to boot to Windows. Discard changes. You have a profile set and you did some changes and you don't want that to affect your previous settings, you can discard and to redo your configuration. Load. UEFI default is just like on easy mode. Load default. So whatever settings you have done in the advanced mode, right, when you set load UEFI default, you will erase off all your settings and to bring the system to default configuration. First impression when I unboxed this, I was stunned. It was so nicely designed and I got the attention based on the fact of this whole block over here, the armor shielding with the subtle imprints. I like it very much. In fact, I like black more than white, and this does suit my taste. And best of all this heatsink, right, are not meant for show. In fact, majority of this are aluminium. There are no plastic casting on the rear I/O or on the the chipset, where some other motherboards have that. So this is pure performance in cooling. The only thing that you need to take note is that these are passive cooling, so make sure that you have good airflow in your case so that you will just push all the hot air away from the armor shielding and the rear I/O heatsink or the VRM heatsink. Another thing is that this motherboard is packed with features, and if you are a gamer, right, requires to store a lot of games with big gigs and such, you never run out of space. Even if you fill up all the 5 M.2s, right, you still have 6 SATA ports for you to connect your SSD and your hard disk. And best part of all, you are provided with 8 USB type A port. It's more than enough for you to plug things like your headset, your microphone, and maybe your short key stream decks and such. It's more than enough, even your camera. Now besides this, something which I would like to highlight, which I've forgotten to mention, is this connection point over here. I missed out on the connection. This is another 4-pin PWM fan connector. And why do I want to highlight this? If you were to plug this motherboard in your case, where you have your top fans, your radiator fans, your front fans, your bottom fans, and your rear fans, or even the bottom fans, there are more than enough headers. In fact, they are reachable. For example, your radiator fan, which you plug over here, and along with it, if you have ARGB, right, you can make use of the ARGB points over here, the header, to make use of the in-house. Yeah, true enough, I like this, the in-house UEFI ARGB program to control all these strips. I mean, this ARGB connectors. Same goes to the bottom, which is here. And as for the front, right, you can either plug the fan header, the fan connector over here, or to the bottom. And for the bottom fans, right, it's either here or here. And as for the rear, one thing good, you can tuck the cable underneath this armor shield and to plug it over here. So it's hidden where your fans is located over here, which is a nice touch. The layout is superb. I enjoy the layout, and best part of all the fan headers except for the CPU fan 1 and your chassis fan 5, which is here, is 1 ampere. The rest are rated 2 ampere. So you have more than enough amperage to daisy chain your fans. Even if it's rated at 0.5 ampere, you can plug up to 4 fans, not a problem, for all these 2 ampere headers. Now, the only thing that I dislike about this board is this M.2. If it's empty, right, it just rattles. Very noisy. So imagine that you plug this motherboard in your case, and when the motherboard vibrates, right, see, it will just rattle. Now I find out a way to tackle this problem. It's either you populate with a Gen 5 M.2, whereby you sacrifice the speed lane from 16 to X8 on your PCIe slot on your graphic card. You can do this. Since it's rattling, it's based on this mechanism over here. What you can do, use thermal pad 2mm thick, place it over here. Okay, obviously I've already done that. That's why I'm telling you. And a safer way, instead of some others, other reviewers, right, they have placed things that is conductive or fire hazard. I find that placing thermal pad is much better. So when you have both ends, right, at the end you don't have to paste that much. It's just a small thermal pad. Okay, so right now when you place it back, and to plug it, where's the rattle? I don't hear any rattle at all. See, I'm hitting it. So this will stop the top M.2 from rattling, and you're using the correct material, as in like thermal pad instead of other material like maybe metal or such. So this will prevent accidental or electrical short, or maybe insulating the heat from dissipating to your heatsink. So with this say, right, you have your thermal pad, and if the M.2 is to dissipate heat through the side of this tool, okay, let me just pull it out. Okay, at this channel here, see this channel and this channel, it will still contact to your M.2 shield at the top, and you will dissipate heat. So this is one of the tricks that you can do. It doesn't cost a lot, and it's way more effective than you place other material. See, it doesn't rattle. Alright, there you have it. Hope you guys have enjoyed what I've shared with you, and I'd like to thank ASRock to have provided this board for me to share with my viewers, and also to Tech Dynamic to done the arrangement on the delivery. Now before I go, I do have something to talk about, which is the next video. Now a lot of you have been waiting for the Nova. This is a more exciting board and a more high-end board, but it doesn't cost more to break your bank. In fact, it's about 50 to 60 Sing dollars more compared to the Riptide, and this has more function, which I will talk on my next video. With this said, right, if you guys are new to my channel and want to know how the Nova function compared to the Riptide, do remember to subscribe and to click on the notification bell button. Till then, take care, goodbye, see ya.